Yeah, so we can launch the redemption process. We have the Ian is making a small change, and then we launch tonight. Sweet. I doubt there's anyone left who's interested.
Oh, they're there. They're out there.
I'm going to use it as soon as possible.
So am I. Actually. So there's a lot. Go ahead. Yeah, absolutely. Yeah. And okay, so that one is done. It's been a long, strange trip. Okay. Thanks, Ian. I'll attend to that shortly. We have lots of other updates. So the biggest piece is that now I have at least on the technical front, I have an if and only if proof on the trace and consensus thing. So if you have a trace, then you have a consensus. If you have a consensus, then you have a trace. The latter part was easier than the former part, but that's
amazing.
It is amazing.
I'd like to see a walkthrough of what you'd have, unless it's level 5.
Yeah, I mean, I did a walkthrough last time.
Yeah.
Basically, the main thing is, if you have a consensus mechanism, then you have a way to. So all this is predicated upon having a category. I realized recently when giving the Casper update on Monday, we didn't do a hangout, but we did it over Skype. Then giving a Casper update on Monday, the best way to describe this category is it's a category of smart contracts and types for the smart contracts. And if it is the case that the composition in that category is a certain kind of parallel composition, which is what it is in our case, then if you have a trace, if you have a consensus, what the consensus does is it forces the two processes which are overlapping in the composition to agree. And that's the function of the consensus, and so it gives you the trace. The other way, when you have the trace, what the trace does is it forces the two processes to agree, which is the building blocks for your consensus.
So what is how did we define overlap?
So I gave the picture before. Let me give it again.
We could do it during Dev Stand Up if you want. But.
No, it's totally easy. I just need to move the thing into the camera. And there are pictures of this in the POS channel on Slack.
They were just so low resolution. They weren't really legible.
Oh, okay. I'm making diagrams for the paper that we're going to.
Cool.
Yeah. So basically, the category that we're building is P and P prime are two smart contracts, and they're typed as running from X to Y. That's P, and P goes from Y to Z.
Right.
Now, what that really means is that P satisfies conditions so that you have an X part of P running in parallel with the Y part of P. And the Y part of P is marked as, think of it as like a kind of generalized output. This is how it communicates with the outside world.
Sure.
Right? And then here, the fact that P prime is running from Y to Z means that it has two parts running in parallel. Mm-hmm. One is the Y part, and the other is the Z part. And you can think of this as how P prime takes input from the outside world.
output of P is input of P prime.
Exactly, but it's not like plugging two wires together. Think of this as a protocol that they share.
Oh, okay. Like we could just imagine like the body of a protocol.
Like high watermark or RabbitMQ, AMQP protocol or the gossip protocol in Ethereum or whatever. So this is a protocol that they share, and what the trace does, what the consensus does, is it insists that the transitions here have to be mirrored over here, and the transitions here have to be mirrored over here, which is what we've been talking about all along, right? Mm-hmm. Just basically all of the transitions have to, and in fact, if you do the analysis, you can find exactly those places where they have to be, where you have any sort of source of non-determinism, and those are only two kinds of races, right?
Yeah.
Right. So what's really happening is that any race over here, the winner of this has to be exactly the same as the winner of that.
Okay.
And what you can show is if you have a trace, then that must be the case.
Right. So does this? So in terms of validators, what does this? I mean, I guess who would be operating P and P prime? Are these just two different copies of, or these conditions only arise in the case that they're
these are two. So how this gets assigned to validators is a separate issue. Right, but essentially the trace is what the validators are running.
Yeah.
Okay, so the trace is a set of the trace is a family of processes or protocols.
Right. Yeah.
That ensure that these two agree on all the races.
Cool.
And that's exactly what the consensus is. So I now have both directions. If you have the trace, then you have consensus. If you have consensus, then you have a trace. So what that says is that the trace is the tightest equational or logical characterization of consensus.
Right. So is this? This sounds like it's extendable to both the logical propositions view and the current view that Ethereum uses, right? I mean, it's generic to both, or is it specific to the by proposition route?
There's a lot to unpack in your question. We don't care what the consensus algorithm is. So if you have a consensus algorithm, like even if it were centralized, then it satisfies the conditions of the trace.
Right. Okay. Well, that was my question. This is a generic representation then of pretty like any consensus algorithm.
Any consensus algorithm, which allows us for heterogeneous, which is important because it allows us for heterogeneous consensus, right? So in particular, as the consensus algorithm changes over time, then you have to be running multiple consensus algorithms. So you have to have conditions under which you can prove the end-to-end correctness of the network, even though you have different versions of consensus.
Right. Well, that's really, really crazy useful. That's awesome.
That's exactly right. It's very
So it's pretty much in any environment, if you have conditions which you'd like to reach consensus on, it's applicable. That's great.
Right. So what we have, so the way to think about it is the equational characterization of the trace is the safety spec for any consensus algorithm. Now that doesn't insist that the consensus algorithm is decentralized. That's an additional set of characteristics that gives rise to a specific set of message flows in Casper. But you know that if a particular version of Casper satisfies the equations, then it's safe.
Yeah.
So that is the safety spec.
Oh, cool. Gotcha. I'd like to talk more on it when we have more time.
Absolutely. So that's you. So let me just draw the conclusions here.
Greg, you need a whiteboard.
I need a whiteboard. I do. Okay, so here's the so what we've said is we have so in general, category theory says the world is made up of different kinds of cells, right? You have zero cells, which you can think of as
like empty.
No, these are sometimes called objects. Sometimes they're called types. One cells, which are arrows between or morphisms between one cells.
And they compose.
Right.
Yep.
Morphisms between zero cells. So typically programs are one cells. Programs, contracts, protocols, etc. Programs are one cells. Okay.
Like IO, yeah.
But not just IO, right? So basically any smart contract should be a one cell.
Yeah.
Okay. And then two cells are these are like transforms on programs. So think of these as program transforms. So it rewrites. So like when you start with a program and you refactor it and you end up with a different program that does the same thing, that would be a two cell. Program transforms.
Does that include compilers?
That includes compilers.
Okay.
Yes. Okay, so two cells are program transforms. So this is, and then 3 cells and 4 cells and yada yada yada. Okay, so this is the category theory, and what we're doing is we build a category of smart contracts and types. Okay, and then the smart contracts for us are Rolang programs.
Sure.
So for us, smart contracts, which are one cells, equal Rolang programs. And then our types, we generate, so types, which are the zero cells, generated
from one cells, yeah.
By ladle.
Yep.
From one cells. Okay. And so this, and then there's a special kind of composition which derives from our Rolang semantics. Okay, so these make our category, and then we can prove that it is traced monoidal. So this is a special kind of category, and the monoidal product here is roughly equivalent to the parallel composition of Rolang programs.
Sure.
Okay, so we can prove that it's trace monoidal, and then the trace is consensus.
All right, we're losing your writing. Just
sorry. The pen is getting
screen border.
Yeah, so I should do this on OmniGraffle.
Well, yeah, but so 0 and 1 cells.
So roughly speaking, so how smart contracts and types, right? The smart contracts, the Rolang programs, the types are generated from the ladle algorithm that Mike and I have been working on, from the Rolang programs, and then you can prove that category is trace monoidal, and the trace is the consensus algorithm. So that's how.
So how does 2 cells fit into it?
So the way 2 cells fit into this is that the rewrite rules on the programs. So the COM rule on Rolang programs is a 2 cell.
Gotcha.
Right. Cool. So and all of this is detailed in a series of papers, right? So so in the Hydra 2015, that's when we gave the basis of this category.
Right.
And more recently, we've been showing how that category, how the types in this category, how the types generated by ladle are related to that category.
Yeah. So I've heard you mention at length, and it's fairly standard in terms of a material that's out there. But so zero cells you mentioned as objects, and types we can correspond to propositions. So I'm not really exactly sure how to phrase my question, but it seems like at least running the trace on objects or on types would be a foundation for the by proposition approach, right?
Yes, that's right.
Roughly speaking, obviously,
I guess again, sort of the point of Curry-Howard in this particular setting is that the right orientation with respect to Curry-Howard is that smart contracts should be one cells, and then these smart contracts will correspond to proofs. Proofs of what? Proofs that you can get these types by gluing these programs together.
Okay, cool.
Right. So essentially, the programs are witnesses of the types as you glue them together.
Yeah.
So that's the major technical update. Mike and I have also just this week submitted an abstract to Calco 2017. So we have a paper submitted into MFPS and a paper submitted into Calco. These conferences are co-located. Let's see if I could try to describe this really, really briefly.
How much of this traced monoidal work came in conjunction with consensus people? I mean, Ethereum researchers.
Well, I told them of my intuitions back in January of 2016.
Yeah.
Right. So basically, when I was looking at the loop, the betting cycle inside Casper, I noticed that it was an iterated function system. Mm-hmm. What we were trying to do is to prove that would converge. And as a part of looking at the whole convergence and the iterated function approach, I began to realize that it had it turns out that in the kind of setting that we're looking at, you can always get an iterated function system from a trace.
Yeah.
The trace is it's a kind of iterated function system. Mm-hmm. So then I started looking more carefully at the trace, and it literally took me a year before I realized what all the examples were doing. So all of the example, like if you look at the linear combinatorial algebras by Haggerty and Abramsky, then what you discover is that all of the examples, whether you're talking about partially injected functions or relations or the probabilistic models, all of them are basically saying that in the overlap on these computations, the trace forces them to agree.
Yeah, that's cool.
Right. So and the penny didn't drop for me that, okay, this is exactly what the trace is doing until a couple of weeks ago. But now I see exactly what the trace is doing and why. And that led me to understand that the trace is the consensus. Intuitively, I felt that it must be.
Yes.
I didn't have a sense of how to prove that until a few weeks ago.
Well, the only thing I'm thinking of is just I remember when I visited Seattle and I went to one of Ed's friends' parties. There was, and I think I briefly told you, but there was a he used to be a geophysicist and he worked in quantum statistics, but essentially he was applying neural networks to developing pattern identification for market swings, right, which are scale invariant next to large trend changes. And because they're scale invariant, it means that they're involved in a feedback loop.
Right.
So it's possibly predictable. So I was just, feedback loop.
Yeah. Well, there's probably some considerable overlap. The main thing about trace, and I've drawn this picture before about I'll draw it again, is, let's see. So if you have a smart contract P, then so the way to think about it is generically you have these bundles of wires, okay? These are not individual wires, but they're bundles of wires.
Sure.
And think of this wire, if it were a single wire, then this is where it, let's say it writes, okay? And then, and this is where it reads. So think of these as...
Are those plus and minus?
These are plus and minus. I don't know if they're big enough.
Okay. You said up is right, bottom is read?
Yeah, so think of that as...
In
well, we use X to write, and we use X plus to write and X minus to read.
Sure, yes.
Okay, so the wires are coming in pairs, right?
Sure,
and
so bundles of wire pairs, gotcha.
And then over here we have, we want to read on Y minus, write on Y plus.
Right.
Okay, so then if you want to communicate, right, with some other smart contract Q, right, then it's going, on the left side, it's going to have the Y plus, right, and on the right side, it's going to have the Y minus. And then over here, you have some Z minus and some Z plus, right?
Sure.
So see the minus, plus, plus, minus, right? And now it's pretty obvious how you have to glue these together.
Yeah, just draw, yep.
Right, you have to glue that to that, and you glue that to that, right? So this is effectively, twisted pair composition. And that is the trick that we're using in our category, is this twisted pair composition.
Cool.
Yeah. It's nice that it all falls out.
Yeah, definitely.
So all of the pieces, every piece of the puzzle that we've been working on has a place, right? There's no effort that we've been doing that was sort of wasted in any way. All of the ladle algorithm is necessary to generate the types. The row lang is necessary to write down the contracts. Even the com rule is a part of a 2-cell description in a particular category. So all of the pieces fit together. And then just now to finish it off. So the important thing is that the lambda calculus, which is, you can think of as the functional models of computation. So effectively, solidity is a kind of, lambda based. That's the most natural model for solidity. But that model has variables in it. But you can so you write things like.
Yeah, well, I mean, it's just like variable bindings, right?
Right, exactly. So when you
bind something to an expression, and
lambda x, p, and you apply that to a q, right? Then the q gets bound to x inside p. So this rewrites to p in which you have q for x, right? So now it turns out that there's a model, there's an algebra called SKI, where you don't have any variables. You just have these terms, and this was developed by Moses Schoenfinkel, and then.
You mentioned it in your ladle paper. Yep.
So anyway, so the point is there are no variables in SKI. All right, and so for the longest time we knew how to get rid of variables in sequential computing. Basically, in sequential computing we could get rid of them. And the question is how to do it in the concurrent setting. So Yoshida came up with a set of combinators. So this is Nobuko Yoshida in sort of the early 2000s, late 90s. But they didn't get rid of all the nominal phenomena. So you still needed fresh names and replication. So Mike and I, this week, we've published 2 papers which get rid of all the variables. So basically what this says is you can go from Rolang to an algebra with no variables. And we've given 2 algebras. So we've taken Yoshida's combinators for pi and added reflection. And this gives you something like SKI. There are no variables.
I don't understand the significance of not having variables.
Because so let me just finish this, then I'll explain.
Sure.
And then we can also take SKI and beef it up with concurrency plus reflection. And get another calculus which has no variables. The reason that's important is because the channels, ports, names, variables, all of that ends up giving you a lot of extra stuff in the semantics that you have to account for.
Gotcha.
So in particular, you constantly have to be accounting for things like, lambda x dot p is the same as lambda y dot p, in which everywhere you see an x, you replace it with a y.
Oh, so it's kind of redundant.
So this is called alpha equivalence.
Yeah.
Basically, it says the programs are the same under uniform variable renaming, right? And that's a refactor that a lot of IDEs support now, right? They support going and renaming all the variables consistently.
Yeah.
So you're constantly having to be keeping these kinds of equivalences around. And you also have to handle this idea that, Z is fresh in P, which means if you go and look at all of the names in P that aren't bound by some binder like lambda, then Z is distinct. Z is distinct from all of those.
Sure.
So this notion of freshness and abstraction or binding and alpha equivalence all have to be accounted for in your models, which makes the models much more complex. And what we've done is to show that you can treat all of this like syntactic sugar.
Yeah. Preserve the semantics, but get rid of the variables.
Get rid of the variables. And so what this does is it gives you a kind of machine code for concurrency, which means that
like graphic lambda calculus.
It's similar to the graphic lambda calculus, except that it has notions of concurrency built in. So the graphic lambda calculus, since it's a lambda calculus, it doesn't have non-determinism. So what I mean by that really quickly is that if you have a term in the lambda calculus, say m, right? And let's say that you could rewrite it this way to m prime, and you could rewrite it this way to m double prime. Okay? Then that means that there's some m triple prime that both of them evaluate to. Okay, this is called confluence. So that is lambda calculus. If you're a lambda calculus, you have this property, right? But in real systems, real world systems, you have non-determinism. Right? So in the case of non-determinism, you have races, right? In one world, Jim gets the airline tickets, and in another, HJ gets the airline tickets. And there isn't one world that unifies where they both get the airline tickets, right? So this idea of confluence is not real world-like. It doesn't include the non-determinism of the real world that has to do with, exclusive control of resources. So the lambda calculus is farther away. It's a less detailed picture of the world than things like the row calculus.
Well, yeah, I mean, and well, the idea of non-determinism between calculus is just like, I mean, it's like capitalism and it's one world. So it's designed like that intentionally. We don't really want a world where both people get both things.
Well, yeah, I mean, if you want to be able to account for economic phenomena like the blockchain, then you can't use a model of computation that looks like this.
Yeah, exactly.
Yeah. You have to be able to express races.
Yep.
And you have to be able to express races in a setting where you have exclusive control or destructive access to resources. So that's the difference. So the graphical lambda calculus is set in a world which is less like the real world. That's the basic difference. Anyway, so those are there's an archive link for the first paper, this one, and there will be there's a GitHub link.
We can't actually see that, Greg. It's a little bit too.
Oh, sorry. Anyway, so there's an archive link available, and I'll post it in the Slack channel for this paper. And there's currently a GitHub link for the one that's about SKI, and there will be an archive link for that by the end of the week, because we have to submit the paper to Calco by the end of the week. We submitted the abstract yesterday, and we will be submitting the paper by the end of the week.
Well, that's big news. Congratulations.
Thank you. We're excited about all of those and how they fit together with what RChain is doing.
Yeah. So I guess my more direct question is the consensus approach shared with Ethereum?
So there are lots.
That's kind of. I mean, it's kind of interesting territory.
There are lots of overlaps, but Vlad has a different algorithm from Vitalik.
Yeah.
And our algorithm is different than Vlad's and Vitalik's. But the important point is that our safety calculation is generic. We're able to address the issue of of heterogeneous consensus algorithms.
Yeah.
But with one notion of safety, and that's important for realistic networks. And then the other thing that I can now answer definitively is that in the category where your one cells are Rolang programs and your zero cells or your types are the types generated from Ladle, then what you have is a definitive way to turn non-economic consensus into consensus that uses slashing conditions. So I now have enough structure to prove that this is always possible.
Yeah.
With Vitalik, he demonstrated a couple of examples, but he doesn't have a proof that that's the case. Mm-hmm. Here we have a framework in which we can state what a consensus algorithm is. It's a trace. And then we know how to apply a transform to the trace in order to turn it into an economic version of that same thing.
Yeah.
So that puts the whole idea of slashing conditions on better footing.
Sure.
So that's to me that's huge, right?
Yeah.
That's a really really big win. All right. So
the consensus algorithm is able to evolve to better guard from the FLP impossibility.
Well, I mean, we're never going to guard from FLP impossibility. Is just it's a fact of life. It's something you have to live with. So what that says is under certain conditions with respect to asynchrony, you're not going to be able to reach a decision. So in order to reach, so you have, essentially what you have to do is you have to put some kind of scope on the asynchrony. There, you know, and typically what this comes down to is you have some kind of timeout, or you have some kind of, you know, you have some kind of fixed relationship on you bound the amount of time that you're willing to sit around and wait. That's what it comes down to.
I guess in terms of evolving, you can have more than one kind. Does that mean you can, you know, improve the method over time, or?
Yes, that's what I was saying, right? So the algorithm itself has to be able to the algorithm has to be able to evolve, right? We're gonna at a minimum we're gonna find bugs in our implementation, right? That's a guarantee. We're gonna find bugs in our implementation, and so we're gonna fix those bugs. And do we have to have a hard fork? Well, not necessarily. It's only if the bugs, you know, break the proof of the trace conditions that, you know, we have to have a hard fork. So we can plug together any of the consensus algorithms, the components of which satisfy the trace conditions.
It's awesome.
Yes, that to me, now we have a framework. And last year, the framework that I was looking at was much more computationally expensive because I was invoking reflection a lot, right? So I had the reflective machinery happening. You know, I had Casper inside Casper inside Casper, and I don't have to do that now, right? The trace doesn't the trace characterization eliminates that burden. Cool. So those are those updates. Ed, any updates from the holdings?
Yeah, I don't think I can top that. That was so awesome, Greg, and Joe. Thanks for that engagement too. Wonderful. Well, I think I survived. I thought I survived April Fools without any funny business, and then HJ forwarded the article how monopoly money, the obscure law in the Nixon administration era. It got me. How no, cryptocurrency, you don't have to follow any regulations.
That's pretty funny.
So I was really happy there for a little while. Had a couple of great conversations with Greg and Navneet and David and Joe about terminology, and put a diagram up on Slack. One of them, Joe was using the terminology of namespaces and their importance on how virtual machines are scoped and how nodes. And so he and I were struggling with this terminology, and as we talked through it, it just became simpler to introduce the concept that RChain essentially supports multiple blockchains. In effect, now that may change a little bit, but so we've talked about this before here. Is that one node may care about one blockchain, and another node may care about another blockchain. In effect, a different namespace of blocks, transactions, contracts, and so forth. So that really helped, I think, move the conversation along for us. So I was really happy with that progress. I also put an updated architecture overview in Slack because I found myself drawing this on the whiteboard as I talked to various people. So that was I think a good update, and we've refined some things from previous diagrams about like the interfaces and which pieces will be written in Rolang and which pieces are written in Scala, for example. So that was cool.
Yeah, we want most of it to be written, as much as possible, to be written in Rolang.
Exactly.
Yeah. So that way we get maximum flexibility.
Absolutely. Yeah, someone on Slack noticed that we transferred some rocks. What we did was transfer 105, I think, million rocks from the co-op to holdings. And that's part of a contract we talked about many weeks ago, about a month ago, actually. We signed an agreement. And so they're sort of it's putting the structure in place for investment. So the holding company will now has a balance of rocks, and that makes in context with everything else makes the holding investment more attractive. But also, now Holdings has a debt obligation in essence to the co-op, and then the co-op is now formally obligated to develop the platform. So that's what that is. So that's not new, but just the next step on towards that agreement. And then we're also working toward more specific milestones and project plans, and that's progressing a little bit over the last week. Been doing a lot of working on forecasts, including staffing forecasts, P&L, business models, some organizational and legal stuff, just kind of things you have to do as part of business and putting together the whole story around the upcoming investment. Let's see. I just want to make a plug for Holdings and what conversations in particular we want to have up in the coming weeks and months is, as I look at all the dependencies of all the kinds of things that can be built on top of RChain. Of course, it's like an infinite list, but strong wallets is really important. And then especially for commercial applications, identity connections is really important. So those are areas that I'm in particular interested in having conversations about. If anyone has a connection to projects or introductions you'd like to facilitate, I really welcome those. Decided a couple of days ago that I'm going to be going to CoinDesk's Consensus 2017 conference, which is in New York City the week of May 22nd. And that's followed by Token Summit all that week. So for those of you in New York or that are going to be at either of those, let me know. Be great to meet up. I'm hoping I can talk Greg into going that week too, but we haven't finished that conversation.
Yeah, no, I'm pretty much guaranteed to be there. Also, we should mention that it looks like as of today, Kent will be joining us this summer as to work with the co-op.
Yep. Thanks.
Awesome, yeah. Kent. Really delighted about that.
Cool.
And then the last update I had was really just about acknowledgement and appreciation. I know that there's several people on this call, and maybe some that aren't on the call, that are really working really hard, either not getting paid much or getting paid rocks or volunteering their time, and so we don't always recognize that, but I've had a couple conversations this week with folks that are really have been making a sacrifice in terms of their personal lives and time, and just really appreciate it. We're all doing something that's bigger than us, and that's going to really reap a lot of rewards, not necessarily for us making us all rich or anything, but it's going to make society a better place. So I just want to extend my appreciations to everyone.
Likewise, but what was that about not getting rich?
Yeah.
No, I mean it's
I'm just saying that's not our main motivation.
That's right. No, I'm super excited and inspired by the work that people are doing. It helps me get back to it after all the ups and downs and twists and turns this plot has taken. Just the work that everyone has been doing is super inspiring to me. So yeah.
Agreed.
Yeah. Cool. Well, let's see. Are there any other updates?
So Greg, you mentioned actually before we started recording about the redemption event, and I think it should be repeated because it wasn't recorded.
Oh yeah. So I did repeat it after Christian hit the record button, but I'll say it one more time. The link goes live this evening. So we'll post it, I guess, in announcements in Slack. But the link will be live this evening.
Congratulations, guys.
Thank you.
Congratulations. This is the redemption.
Sort of. Yes. I've been super. Again, I was really inspired by the people who gave us quality work. I was less inspired by people who didn't give us quality work. But I'm really, really happy with the way so many people pitched in. Yeah, looking forward to getting rocks into people's hands. I mean, I think the most important thing is really just that people be recipients of rocks so we can get this economy underway. I think that's the most important thing here. Awesome.
What is there a current? What's the current document that describes that documents the process?
It's on the site.
Okay.
So when you hit the landing page of the site, here, let me just.
No, I missed it somehow.
It's on the RChain.coop site.
Oh, it's not a separate document anymore. It's just the site itself should be clear enough with the instructions and the terms and conditions.
Okay.
Is that what you meant, Greg?
That's exactly what I meant. Hold on. Let me do a. So here, I'll just do a quick screen share.
I think the most important thing about this is that the Ethereum address that you provide has to be one under your control.
That's right. So
yeah.
So if you look here, the process is spelled out entirely. So the process steps are: you go to the check eligibility tab, or click the button. You supply a name, an email, the BTC address that holds. Then this needs to be an address that is under your control, not an exchange address, and it holds the amps that you wish to redeem. You supply an Ethereum address where you want your rocks to be sent. This should be a private address that's under your control, not an exchange address. So repeat, the AMP source address is a private address, not an exchange address. It's under your control. The ETH address is likewise, it's under your control. That's the ETH target address where you will be receiving your rocks. So click the eligibility button, and then if your check eligibility button, and if your amps are eligible for redemption, then you'll receive a new BTC target address, right? So if I click this, oh, of course, Ian has changed the.
This is on the RChain.coop website?
No, it isn't.
Not yet. Right. Oh, no, sorry.
No, it's a separate link that will be available, made available on announcements.
Right. Okay.
Greg, you need to put HTTPS.
Yes, thank you.
Yep.
Okay.
Greg, do you want the current link?
No, it's okay.
Okay.
How long? When is it gonna end? When will it conclude?
So it runs about 10 days.
I'll put the domain name in.
Okay, I'll put the domain in. But I'm getting rid of this so that it's live, right? So what you'll do is you'll put your first name, you'll put an email address, or you'll put your full name, and you'll put an email address. You put a reasonable AMP address in here. If you put bogus AMP addresses, we will just throw them away and not tell you that it was bogus. And this won't be a DOS attack because of the way we're handling this. So if these are bogus, we just throw this stuff away, and we're not going to help you out by telling you that it was bogus. And then you agree to the terms of service. You tell us that you are in fact not a robot, and then you submit. Oh, of course. What happened there? What happened there? Do we know? Awesome. Well, what you will get back is the address. So it looks like when we changed to SSL, something got changed on the back end here.
Well, you also just entered a bogus address.
No, that doesn't matter. Like
Okay.
I said, it really doesn't matter. All of our testing includes entering bogus addresses. So I'll have to go back and see what happened there. But what you'll get back is an AMP address. You send that to the thing, and and you send. And if you send again tainted AMPs or anything, they will be bounced back. So. But quickly, let me stop the screen share. Kent, do you guys know, or Ian, do you know what happened there? Did you try it?
No, I personally have no idea.
Ian, are you still there?
Yeah, I haven't been through that.
Okay. Interesting. All right. Well, we'll fix that, and the site will be live this evening.
Do you want to try a second time as a run through?
Oh, we can try it for sure, but
I mean,
it should have. I've tested this out the wazoo. So of course, whenever you try to demonstrate it.
you might want to, suggest or give an example of my Ether wallet
Let me just.
for people who aren't sure what to do there.
Yeah. Okay. Well, that's somewhat embarrassing, always.
And you probably want, some method to get help.
Okay, so it looks like, the check eligibility failed. So the request was denied. Let me go see if that's running. And you guys can fill up the air while I'm figuring out.
Well, I'm excited that you guys have reached this point in the redemption process, even if we're debugging it at the last moment. I want to acknowledge the team for getting here, and acknowledge the community as well for being a part of it and sticking with it this long. I look forward to expanding the community in Brooklyn and doing meetups, and also being a part of the developer team and helping to develop that. So I'm super excited to get that started in Brooklyn.
Cool.
That's awesome, Nathan. Thanks.
I see what's going on. Yeah. Right. So sudo kill slide 1501 and 32260, and then message. Okay. All right. So allegedly they're both running. I think I see what's going on. Hang on. Okay, so it should. Check eligibility.
Hey, I wanted to make a comment on something Jim said a little while ago. Is on Ethereum wallet or whatever. One way that you'll be able to see rocks is only if you kind of reference the custom contract for rocks. And then, like in the case of Mist, for example, that goes to wallet.ethereum.org, then if you're referencing that contract, you would see balance. So you could set that up in advance, and then that'll help you see when rocks arrive in your Ethereum wallet, for example.
Yeah. So what happened with the site was we switched over from HTTP to HTTPS, and there was a small error there. So that will be resolved.
Also, the CAPTCHA, was that reset?
The CAPTCHA worked. Oh, right.
Well, the CAPTCHA is still not working on HTTPS.
Okay.
Under the redemption subdomain.
Oh, okay. It's okay. That's probably what's going on. Yeah. So the CAPTCHA resolved, but then the right key wasn't set for the domain. Yeah. Okay.
Yeah, I think so.
Okay. All right. So then I'll check that after at the dev stand up in a couple of minutes. Cool. Well, always a never-ending source of humility and embarrassment. But good fun. Okay. Well, I'm going to jump over to dev stand up, and we'll see you guys next week.
All right. Peace.
All right. Ciao.